All right, so here's 7.3. This is full stoichiometry. So we've built up to this point where in 7.1 we learned about mole ratios. In 7.2 we learned basic stoichiometry mole-to-mole conversions. In 7.3 what we're going to be doing is we're going to be doing full stoichiometric conversions. We're going to be going from grams to moles to grams. What the heck does that mean? Well, let me break it down to you guys with this example. Consider the following combustion reaction. Now remember, what is a combustion reaction? It is fire, basically. And so here what we have is we have propane, C3H8, combining with oxygen in order to make H2O and 3CO2. What this is asking is, hey, if we have 200 grams of C3H8, how many grams of H2O is produced, assuming an abundance of O2? And so, what we did in 7.2, the way that we tackled this is we used the mole ratio, right? And so we said, well, here what we have is we're trying to get grams of H2O, and, we're given grams of C3H8. And so, it's 1 mole of C3H8 for every 4 moles of H2O, right? And sorry, let me write that out fully. For every 4 moles of H2O. And so, 200 times 4, that'll be 800. And you're right, except for the fact that, if you go to try to cross these, right, you have grams and moles, and moles can't cancel grams, right? What we have here is we have a mismatch of units. And so, oh no, this is bad. Grams and moles, you can't use a mole ratio if you have grams, right? That's the fundamental problem we're having here. You cannot use a mole ratio if you're in grams. And so if only we had some sort of step, some sort of tool that we could use in order to convert from grams to moles, and then we could use this step. If only we had spent an entire lesson learning about a conversion of grams to moles, which rhymes. This is my joke with you guys. It says solar sass, right? Molar mass, right? We have molar mass. We know molar mass, right? And so actually we can do this, right? We can convert first from grams to moles. And the molar mass of C3H8 is it's 44.1 grams of C3H8 for every 1 mole of C3H8. And so if you do this, what you'll get is grams will cancel and you'll be left with moles. Now, you could actually just kind of like do this on the side because I think sometimes students get confused. They're like, wait, I do this and then how does it go to the, right? Basically what we did, if you actually do 200 divided by 44.1, go ahead and put that in your calculator, right? What you would get kind of in this intermediate step is you would get 4.535, I'm sorry, this is sig figs, I didn't write it as it was supposed to be. So this is 200.0. So we actually have this number of sig figs. This is 4.535 moles of C3H8, right? And so now this will multiply it by this, right? So this is what we got in the intermediate step. I'm not gonna do this though because you don't want to round in between. And also it's annoying to be like, okay, 200 to 1 mole, and then let me write this, and then let me multiply it by this, and then we're gonna have to have another step, and then to keep breaking it off in the middle, it's kind of annoying. However, if that helps you, go ahead and do that, right? But that's why I'm kind of doing it all together like this. So 200 times 1 divided by 44.1, 4.535. Now, you're going to take that moles of C3H8 and you're going to multiply it by this, by the mole ratio. And so now moles of C3H8 will cancel out. And again, if you were doing an intermediate step here, what we would get is we would end up with 4 times 4.5 is approximately 18. Specifically, it's 18.16 moles of H2O. Now, we're almost there, right? We have moles of H2O, but we want to get to grams, right? And so how do we go from grams to moles? Again, right, just the opposite, same tool, molar mass. Specifically, we're going to use, let's see, we have moles of H2O here. So we're going to put moles of H2O on bottom, and we're going to put the molar mass of H2O on top. 18.02, and so now then moles of H2O will cancel and we'll be left with grams. Again, if we were to write this out as an intermediate step, what we would get is 327.2 grams of H2O. And so there you go. But again, this is actually what we want to put in here. Now, but here's the thing though, actually, which is why I don't recommend doing these intermediate steps. You could do these intermediate steps, and why I'm writing it out for you guys is so you guys can understand what's happening. But I recommend just doing 200 times 1 times 4 times 18, getting some number up here, and then 200 is really 200 over 1, so, and then just do 1 times 44.1 times 1 times 1, and put that here. And then do this divided by this, whatever you get up here, divided by whatever you get down here. And what you would get is, you would get, also 327.2. The danger, well, first of all, actually, let's see. Do note that, right, we got the same thing, right? Regardless of how you do it, you get the same thing. The issue is sometimes you might run into, because you round in between, you might get a different answer here at the end. Now, it doesn't matter that much, and I'm not a stickler about these kind of things. I care that you understand the concept, not that you do it exactly the way I want you to do it. But point is, you know, if you just do it like this, it's so much easier, right? It saves you so much time. Yeah. But you could, you know, kind of do it in between. Just be careful about rounding, okay? But anyways, point is, we get 327.2 grams of H2O by doing 3 steps, right? We had our mole ratio, so let me kind of put that in blue. We have our mole ratio here, and we kind of sandwich it in between 2 steps of molar mass, right? And so really this is just, it's the same thing conceptually as 7.2. What we're doing is we're just adding on 2 steps between, which we learned back in Unit 6, right? And so really there's nothing new in 7.3, it's just combining what you already know. And so we're going from grams to moles to grams, which is why I call it grams to moles to gram conversions, right? Because that's really what we're doing. We're going from grams to grams to get our answer. And so this is how you do it. Starting off with grams, you have your mole ratio, you sandwich it between 2 molar masses, and you'll get your grams at the end. Now do note, and I do want you guys to be careful, because you don't always have to do all 3 of these steps. Sometimes if, for example, they give you moles of C3H8, right, then you really didn't need this step, right? You could have just started off with using the mole ratio. Or if the question tells you, hey, like, how many moles of H2O can I produce, right, you could just stop here, because then you would have moles of H2O, right? And so do be careful, read what the question actually asks you, but if it's a full stoichiometric question, right, you'll do these 3 steps, and you'll get your answer at the end, okay? And so that's how you do it. Let me give you guys one more example just to really drive this point home, but this is an exemplar for how to do it. And so here, let's say we have B2H6 plus 3O2, sorry, that should be yield sign, yields 2HbO2 plus 2H2O. The question is asking what mass of O2 will be needed to burn 22.5 grams of B2H6. So what we're saying is, hey, we have 22.5 grams of this. How much H2O are we going to need in order to make sure that all of this is used up? We kind of think about it this way with sandwiches. It's like, hey, if I have 10 pieces of bread, how many pieces of cheese would I need to make sure that all my breads are used? Right? That's basically what we're asking here. And so how would we do this? Well, same thing, right? We have 22.5 grams of B2H6. What we're trying to get to is we're trying to figure out how many grams of O2 is going to be needed in that situation, right? So you can even kind of label this with grams of B2H6 used, then how many grams of O2 is going to be used in that situation. Well, you know, we know that for every 3 moles of O2, you are going to have 1 mole of B2H6, right? Now, the only issue is we first need to convert from grams to moles in order to use this. And so converting from grams to moles is 27.66 grams of B2H6 per every 1 mole of B2H6. So grams will cancel, moles will cancel, however we need to get to grams at the end. And so we are going to put the molar mass of O2. Again, moles are going to cancel. And this is, again, how you know that you did it right? All the units are going to cancel, and you're going to get the right, unit at the end. Grams of O2, this is good. And so what you're going to get is 78.1 grams of O2. 78.1 grams of O2 are going to need to be used in order to use up 22.5 grams of B2H6. So there's your final answer. Now again, just let me color code this for you guys so you guys can see it again. We have a mole ratio. It's exactly the same as before, but what we need to do is we need to sandwich it in between 2 molar masses. in order for the mole ratio, in order to be able to be used. Every single time with stoichiometry, start off with what you have, right? Regardless of, if it's on the left or on the right, it doesn't matter. Just start off with what you have, right? What you want to get to, use the mole ratio sandwich between two molar masses, and you'll get the right answer. Again, caveat though, read what the question is actually asking you for, okay? Before you automatically do these steps. But this is how to do a full stoichiometry problem. Hope this helps. Let me know if you have any questions.